Okay, let's start. So today we've got like a couple of questions, but it will finish soon. All right, so just all right. So we see that we see a system of the ODE and we wanna explain it. Why is it linear? So first of all, we see that x dot, which means derivative of x in terms of time, and y dot as well, and this means -1, 0, 0, minus k. It means this guy. And from here, we call this one a times x, y. And let's assume that, but before proceeding more, we know that from linear algebra courses, if T is a transformation from vector space to another vector space, such that for any v1, v comma, v2 belonging to the first vector space and alpha from their corresponding field, which mostly it can be complex or real numbers, then not then, if T of alpha v1 plus v2 equal to alpha times T v1 plus T v2, then T is a linear transformation. So now here, let x belongs to the space x, including this one, x11, x21. So just, I think we just need to say x1, x2, and y is this guy. So we see that T of x1, x2 plus y1, y2, which is equal to this guy here, A. So this matrix times that x1 and x2. So this matrix times inside this. Oh, yeah, sorry. Thank you. So, okay. So now the knowledge from the like ability of the distributing a matrix inside the parentheses enables us that we can say A times x1, x2 plus A times y1 and y2. So this means T times big X plus T times capitalized Y. Similarly, we can write that T times alpha X, which is A times x1, x2. So So let's write this -1 0 0 minus k times x1 x2 alpha alpha. So this is really same as if I write this guy. So actually this what I did here, it's just redundant. So minus k times x1 x2. So means tx alpha is here. So t is linear transformation. So vector space, the solution of this x and y, they constitute vector space. Another vector space that we have seen, it's like to say a times y double dash b y prime c y, linear second order with constant coefficient, say y1 and y2 belonging to the they are solution, but the solution space is a vector space of dimension. So since this y1 and y2, they are independent and the dimension of the space is 2, so these can be considered as bases. So their linear combination, that's why we call it as complementary solution. Now, we want to explain that y is autonomous. So we see that what's autonomous? Autonomous means we shouldn't have non-homogeneous part. So here we see that we've got this one, minus x, y dot minus ky. Am I right? Yeah. So we don't have any non-homogeneous term, including constants or terms involving t, the independent variables. So if it was like x prime minus x plus 1, or x prime was like minus x plus t squared, then this wouldn't be a autonomous system. So now part C says that which one involves t here?
You have a system involving the independent variables.
No, as a coefficient it can be, yeah. But as here, like independently in the separate term, no. So it will be counted as a non-homogeneous part. So it won't be, the system won't be autonomous. Okay. Now, x prime equals 0 and y prime equals 0. This equation enables us to say that to find the critical point. So minus x equals 0 minus ky equals 0. As a result, x and y is 0. So that's why 0, 0 is the critical point. Part D. So we saw that x prime, y prime is like this. Minus 1, 0, 0, minus k, x, y. So the lambda eigenvalues is minus 1 and lambda equal minus k. So V1 is corresponding V1 eigenvector is minus 1, 0. We can easily write this because the coefficient matrix here is the diagonal matrix. And the other corresponding eigenvector is 0 and minus k. From here, we see that xy is the c1 minus 1, 0 e to the lambda 1 minus t plus c2 is 0 minus k e to the minus kt. In other words, x is c1 e to the minus t and y is c2 e to sorry, minus c1, and this will be c2 times minus k e to the minus kt. Now, assume that we've got this x, y equal x0, y not. So when the t, you don't have a space, when t is equal to 0. So from here, we can see that this minus c1 will be just x0 from here. Okay, t equals 0, so x0, so this x naught will be equal minus c1. And minus k c2 will be y naught. So we will have x equal to x0 e to the minus t and y equal y naught equal minus kt. All right. Now, part E tells us that represent the trajectories of the solution of the curves in the xy phase. I should have done like sage math, but we don't have to do now. I wanted to see that, but I was like busy. So let's see for k equal 1, and we will have to do that for k less than 0 and these cases. Now, this is part E. Since k is equal 1, we see that x or just y over x equal to y0 e to the minus t. I'm from here to here, k equal 1, and x naught e to the minus t. Therefore, y is equal to y0 over x0 equal to times to x. So that's a line. So we have some lines or rays passing from 0, 0. Note that x naught is non-zero. So we see that this guy, so we've got some rays. And as time passes for y, y it's like going to the down. X as well, x0 e to the minus. So all the rays going to the origin. Now, what if x equals 0? This is y, this is x. If x0 is 0, then x equals 0. Then again, y is, so it means we are here, okay? So y is again e to the minus t with some coefficient. So again, this guy is tending to the origin. Now, part F. Let k is less than 0. So we see that y is equal y0 e to the minus kt, or y0 e to the minus t power k. Now, as before, y over x, y0 e to the minus t power k x0 e to the minus t. So we see that from here, this will be y0 over x0, and let's write in this way, actually. We see, so y0, rewriting, sorry, e to the minus t, k. But x is equal to x0 e to the minus t. So e to the minus t is equal to x over x0. Hence, y equal to y0 x over x0 power k for k less than 0. So we see we've got this guy here as coefficient x to the k. But we see that, like, say k is equal to -2, which is less than 0. So you've got something like a constant times x minus 2. So you've got something like hyperbolas similar to that. So you've got this one, y, x. So you've got this guy here. And depending on the constant can be here. Constant can be negative. Can be negative. Now, about the rates, we see that as time's going, as time flies, t going to the infinity, then x going to the 0 as before, but y with this y0 e to the minus kt, k is less than 0, tends to the infinity, positive infinity. So this means the rays will be like this.
Complex coefficients.
This here.
Yeah.
Uh,
So we have x0 is less than 0.
let me see. Yeah, it has not mentioned complex or nor real ones.
K is a negative, not an
But
integer.
x0, y0 they are in the two-dimension Euclidean space. So it, for me, it implies that they should be real.
So would that only work for the case of K is less, is a negative integer, less than 0.
Pardon?
So that solution there, if K is not an integer,
Uh-huh.
it will yield a complex solution.
K is not integer.
So if x0 was negative, K was a negative, negative fraction,
Uh-huh.
I would give a complex coefficient.
So you say that we could write so y0 as complex.
Now y0 can be a real number, but the numerator.
How about, let me see this assumption here. K is a non-zero constant. Yeah, it's not mentioned. The field, for me, it should be real. But if you say that it might be complex, yeah?
Well, if you take, say, x0 to be -2, and then k to be -half.
Let me write K. So x -2.
Yeah, something like that, or yeah, -2.
Mm-hmm.
And then if k was a -half.
What e to the negative half, then we have minus kt, so it should be like this.
And then for your solution, that graph would give a negative, would give a complex coefficient because you'd have -2s down -half.
So this one is still fine with this one.
Yeah.
But this y, it blows up as t is infinity, it goes to the infinity. Did I understand your question? Or you,
right, yeah.
why? So you say that this might be, where should I consider complex?
So I'll try and think it. I might be wrong.
Okay.
So
All right. Yeah.
just for
Mm-hmm.
that part, that solution there for the graph you had,
Uh-huh.
so that part there can be complex based
This
on
part?
yeah.
x0. No, we said that it should be real numbers. X0.
It should be real numbers, but won't you have a negative number to the power of a negative fraction, which can give a complex coefficient?
So x0 as a real to the negative fraction
Yeah.
is okay.
That's okay.
Yeah, so you say that, okay, -2 power. Okay, -half. Yeah, you are right. So this, yes, this, then you are really right. So this constant, this can be yeah, this will be, so y, yeah, now I understand what you mean. So this will be y equal to constant. So x0, yeah, can be complex. So this means x to the minus k. So minus k. Yeah, I have no idea about this. So y,
So it work for integers, but it won't work for anything else. I'll have a look at
yes,
this
yes,
definition.
I see. Even if, yeah, all right, I see. Y, what complex coefficient here? Okay, so I see that. So y will be a complex valued. Y will be complex valued. So this will be, so I can say that then it has the real part, probably it will be like this. Okay, so say, yeah, the real part is like this, and absolute value, but imaginary, we should consider two plots. One with real y, x, the other one is imaginary y with x.
Yeah.
So I believe that it might be the same thing, both real and imaginary part of y. So because this is exponential of this guy here, t over 2, it still is the dominant one, so it will go to the infinity.
Yeah.
Okay, good point. Let me go to the next part. So what happens k between 0 and 1, then with the same reasoning, y0, x0 to k, x to k. So this will be this time. So say k equal half. So we know that y equal third of x is like this. The constant can be negative, and x can't be negative, but yeah, x can be negative because k can be like this guy and this one. So, but they will be as the same reason, the rays will go to the origin. All right, so for the other one, we can see that k bigger than 1, y equal y0, x0, k, x to the k. So this is the parabola absolutely. And constant can be negative. And this should be like this. Okay. All right, let's move to the other question. So you're happy with this, okay?
Yeah.
So before forgetting, this can be like this with the same reason. Okay, so now this guy here. So For this question, we see that, let's assume that x double dash plus omega squared x equals 0. X, let's say z1, my favorite notation. X prime is z2. From here, z1 prime is x prime, which is equal to z2. And z2 prime is equal to x double dash. But we see that from here, we can write it here. So this will be minus omega squared x, which is equal to minus omega squared z1. Therefore, z1 prime, z2 prime is equal to, this should be a coefficient matrix times z1, z2. And what's that? Yeah. And we see that z1 prime is equal to z2. It means 0, 1 here. And z2 prime is minus omega squared 0. Now, z1 prime is x, and z2 prime, I assume that it can be y. So I just rename them. So actually, so this should be x and y. So this will be x, and this will be, instead of z2, it should be y. So this will be this guy, 0, 1 minus omega squared 0 times x, y, which is equal to, if I multiply this matrix, this will be y. So I shouldn't forget x, no, x prime, y prime. And this is minus omega squared x, which is same as this guy. Okay, so I hope you are happy with my notation. So what I did is just Math2800. Now, here, part B, show that x and y can be like this. So we see that x double dash plus omega squared times x equals 0. So the characteristic equation is this guy. From here, we see that the characteristic equation is plus minus omega imaginary number. Therefore, x of t is e to the lambda, which e to the real part is 0. So it will be c1 or a times cos omega t plus b times sine omega t. From here, when we have its complex numbers, we've got some methods to obtain the second one, yt, when we have written, because this one, this x double dash is written as system of the ODE. But we know that y prime, oh sorry, y of t, which was z2 here, it was like equal to x prime. Okay, so that's why this will be x prime in terms of time. From here, we can see that I can just need to get derivative of this x. So this will be minus a times sine of omega t plus b times cos omega t. This is the solution of part B. Part C, we see that we want to write this guy as this one. And we've got a hint here. It means C, this constant is a square root of a squared plus b squared. It means like this. It is C and D, A. And we can see that x of if I apply this alpha, then cos of alpha is from equal to this one, obviously, and sine of alpha will be b over hypotenuse. From here, we see that x of t is equal to what's that? A times cos omega t plus b sine omega t. Now A is this guy, C times cos alpha cos omega t, and this guy is C times sine alpha sine omega t. So where I get these, C cos alpha comes from here, and this C sine alpha comes from here. From here, I see that C cos alpha minus omega t. I use the identity related to the cos. So which is equal to C times cos omega t minus alpha. Okay. All right. Now, yt is the derivative of this guy. And this means minus C omega sine omega t minus alpha, which is equal to what we have here. All right. Part D. Part D. It's obvious. Part E. All right. Part E is
The question on C, because it's just spatial, is it equivalent just to show it in terms of the auxiliary angle and sine? Does that make sense? So if you have your coefficients reversed, then you're just going to give the sine because it's going to be for part C.
part C, yes.
So you can write x in terms of sine and y in terms of cos, which is going to be plus alpha. If
Fair. Here.
Yeah, so for your solutions, you can write A sine B cos instead of A cos B sine. Would that be sufficient, or do you have to go and fix it and show it matches what they said?
So you say that if I change this one is like,
yeah.
No, it will be the same again. So Yeah, so
Yes.
this will be sine. Then instead of this cos, it would be sine.
Yes, and then you have plus up.
Yeah, yes, okay, yes. Yeah. All right. So part E, let's be quick. X is from part C, from part C. X is equal to C cos omega t minus alpha. And Y is equal to minus C omega C sine omega t minus alpha. From here, X over C squared, Y over minus C omega squared. That's obviously 1. And this means you've got ellipse or oval, whatever it is, means so this is like ellipse, y, x. Okay. So you're happy with this?
Yeah.
Ellipse. And
No, it's an ellipse. I can't remember how to find focus points and all that. There's an ellipse.
yeah, so
Obvious, no.
something like this.
Yeah.
All right. So there might be squared, but it doesn't matter. Part F. So critical point is a stable center, but not attractive. It means not asymptotically, I hope it's right, the alphabet, stable. Oh, that was long word.
So you just say it's,
As what?
you just say it's, you can just say it's periodic.
All right. Yeah. Not stable, not attractive, but stable center. Part G and the last one. Okay. Can we finish that? Yes. So x double dash plus 2x prime plus 2 damping part. And we see that y is equal to x prime. And let's say y prime is x double dash, which is minus 2x prime. From here, x prime and y prime will be equal to y minus 2x minus 2y. Okay, so I get x prime here and y prime here. From here, so this is equal to 0, 1, minus 2, x, y. So if this is A, the eigenvalues will be lambda equal to minus plus minus I. Okay. Calculate. And from here, we see that x of t will be e to the minus t, a cos t plus b sine t, and yt will be its derivative, minus e to the minus t, a cos t plus b sine t plus e to the minus t minus A cos T plus B cos T. The first one should be sine. Thank you very much. I will complete just one line and I will send the PDF to you. All right. Yeah.
You say stable track.
It's stable and spiral.
Yeah.
Yeah, it's because the complex and this guy is negative real parts.
Yeah.
All right. Okay.